Good evening, everyone. My name is Sahin and I'm a PhD scholar from Indian Institute of Technology, Delhi, India. Today, I'm going to give a poster presentation on gallium selenide silicon-based vertically standing self-powered van der Waals for heterojunction photodetector with ultra-high responsivity and detectivity. In this work, we report on the fabrication of vertical 2D3D heterojunction diode between gallium selenide and silicon, and its photoresponse properties have been studied. Kelvin probe force microscopic EPFM has been employed to investigate the surface potential of the gallium selenide and silicon interface, and that is used to evaluate the conduction band offset at the heterojunction interface. The photorejection measurement on the gallium selenide silicon heterojunction diode shows an excellent photoresponse with high photoresponsivity, detectivity, and EQ value of 2.8 10^3 ampere per watt, 6.2 10^12 joules, and 6011 respectively. Even at zero biasing, we got a high photoresponsivity of 6 ampere per watt, which indicates that it is a cell-powered device. So gallium selenide is a 3-6 semiconductor which shows an intrinsic p-type behavior, and the 2D3D PN heterojunction based on gallium selenide on silicon has been fabricated by exfoliating intrinsic p-type gallium selenide on top of n-type silicon, and in such 2D3D heterostructure, both advantageous properties of 2D and 3D materials can be utilized in a single device. Now let's talk about the device fabrication procedure. So first of all, metallic marks were fabricated on the cleaned N-type silicon substrate with the help of electron beam lithography (EBL) and electron beam evaporation. And these marks helps to locate the gallium selenide flakes on silicon substrate precisely. Mechanical exfoliation was used to exfoliate gallium selenide flakes onto the silicon substrate. For insulating the electrode over gallium selenide from silicon, a 300 nanometer thick PMMA polymethyl methacrylate layer was hardened at the gallium selenide flake in such a way that it partially covers the flake. Titanium of thickness 30 nanometer with a capping layer of gold of thickness 60 nanometer was deposited on the electrode with the help of EVL and EV evaporation, and this is the final device. Let's talk about the results and discussion. This represents the schematic image of the fabricated device. The AFM image of the particle PN heterojunction found between this rectangular patch which is shown here. The AFM image and the height profile corresponding to the drawn arrow shows that the height of the thickness of the gallium selenide flake is approximately 90 nanometer. And regarding the optical characterizations, the existence of the exfoliated gallium selenide flakes on the silicon substrate was confirmed by using Raman spectroscopic measurements, and this Raman measurement was taken at a 540 nanometer laser excitation of power 40 milliwatt. The Raman spectrum of the sample at the pristine gallium selenide, silicon, and gallium selenide silicon overlap regions have been shown separately, and as can be seen from the figure, the gallium selenide gives three dominant peaks positioned at 133 centimeter inverse, 307 centimeter inverse, and 212.5 centimeter inverse. And the energy dispersive X-ray spectrum (EDS spectrum) derived at the gallium selenide silicon interface also confirmed the existence of gallium selenide and silicon in the heterostructure. The KPFM measurements on the device show that a type 2 band alignment exists at the gallium selenide silicon heterojunction. As can be seen from the plot, the surface potential value of the silicon sample is 146 millivolt greater than that of the gallium selenide film. This was used to extract the conduction band offset value, which came out to 1.4 electron volt. Prior to the fabrication of the heterostructure, we conducted a separate study on the ohmic contact formation on N silicon and P-type gallium selenide. Indium gallium eutectic was found to be ohmic on N-type silicon, and nearly ohmic behavior was obtained on P gallium selenide with titanium gold. The IV curve from the heterostructure shows a very clear diode-like structure with a high current rectification ratio of nearly 1000. Since both P gallium selenide and N-type silicon provide a linear IV relationships, we can conclude the non-linear rectifying nature of the IV curve from gallium selenide silicon PN heterojunction must originate from the gallium selenide silicon heterojunction itself. To study the photoresponse properties of the fabricated device, it was irradiated with the monochromatic light of wavelength 580 nanometer. A significant increase in current was seen as compared to the dark current, which is clearly visible here. To further investigate The photoresponsive effect at the gallium nitride silicon heterojunction, it was subjected to a laser light of varying power densities starting from 40.7 milliwatt per centimeter square to 44.6 milliwatt per centimeter square, keeping the wavelength fixed at 580 nanometer. It was found that at an applied bias of minus 5 volt and a fixed power density of 44.6 milliwatt per centimeter square, the current in the PN heterostructure device increases from minus 1.45 10 to the minus 7 ampere to minus 3.21 10 to the minus 5 ampere, giving a photo to darken ratio of about 221. The photoresponse measurement on the device show an excellent performance with a high photoresponsivity, specific detectivity and EQ value of 2.8 and about 3 ampere per watt, 6.2 10 to the 12 joules and 6.11 respectively at a biasing of minus 5 volt. Moreover, an excellent photoresponse of 6 ampere per watt was obtained even at zero biasing, and it suggests that the heterojunction device does not require any external power to operate. These results show the promising potential of the self-driven gallium selenide silicon-based 2-3 heterostructure device in the field of photodetector. This work may pave the way of designing innovative optoelectronic devices by integrating the low-dimensional materials with the conventional 3-dimensional semiconducting materials. These are some references which I have used while making this presentation. And finally, thank you everyone for your kind attention.